Using implicit differentiation, find dy dx when xy is equal to 12. So how do we do that? Well, step one would be to differentiate the entire equation. So take d dx of the entire equation Okay, now, what is d dx of x times y? What is the derivative of x times y with respect to x? Well, what rule should we use here? We've got x times y, so what rule? Product rule. Okay, I'm gonna get another sheet of paper. Whatever I write on here, you don't have to copy while showing your work. I'm just gonna write some stuff here to elaborate on a few things. Okay, but we want to find d dx of x times y. So how is this product rule? Well, we can think of this as a function. So we'll say f of x is equal to x. And we'll think of this as a function as well. So g of x is equal to y. Now, I want to find d dx of f of x times g of x. Right? This is the same thing as this. Okay, so now we can apply product rule. What's this going to be equal to? It's going to be f prime of x times g of x plus f of x times g prime of x. Okay, well, if f of x is equal to x, what's f prime of x going to be equal to? It's going to be equal to 1, and then 1 times how much? 1 times y, okay, and then plus f of x, which is how much? X, and then times g prime of x. Okay, so if g of x is equal to y, then g prime of x would be equal to dy dx. So what does this need to change to? Dy dx. Okay, so that's what this is equal to. I'm going to put this sheet of paper away, and we're going to try to recall what we just did from memory. Ready? Okay. So what rule did we use just now? We used product rule. Okay, so it's going to be the derivative of this, which is how much? 1 times this plus this times the derivative of this with respect to x. So dy dx. Okay. And what is the derivative of 12 with respect to x? 0. Okay. Now the question is asking find dy dx. So we should get dy dx by itself here. How do we do that? Well, I need to get this by itself first, so I'm going to subtract y from both sides of the equation. And then what should I do? Divide both sides of the equation by x. Okay, so most teachers would accept this, but actually we can go one step further here. I'm gonna get this sheet of paper out again. Okay, so we'll write down, okay, so x, y equals 12, and then we figured out that dy dx was equal to negative y over x. Okay, but if I get y by itself, okay, let's get y by itself. Y is equal to 12 over x. And I change y to this. Then I can say that this is negative 12 over x divided by x, which is equal to negative 12 over x squared. So this is acceptable too. Okay, so this is what we got from implicit differentiation. What if we just directly found dy dx of this equation? What rule can we use? So you actually don't need implicit differentiation to find dy dx here. So we're going to find it a different way, and then we're going to use that different way to double check our answer. Okay, so this is the same thing as 12 times, so wherever you see divided by x, it's the same thing as multiplying by x to the power of negative 1. So, okay, basically 12 divided by x is the same thing as 12 times x to the power of negative 1. And, all right, if I want to find dy dx, what rule am I going to use? I'll use power rule. Where does the negative 1 go? It goes here, so it's going to be negative 1 times 12 times x to the power of how much? I need to subtract 1 here. Okay, so this is negative 12. And then if I want to get rid of the negative exponent here, what do I need to do? Divide by x squared. Okay, so yeah, we got the same answer. We double checked, and we also got negative 12 over x squared. Okay, I'm just going to write equals negative 12 over x squared here as well.